and we march on toward the prize. We're in the middle of Chapter 9 in Thomas's Calculus. This is Math 222 with SUNY Geneseo, and the topic in this screencast for the next 19 minutes approximately is first-order linear differential equations. These are different than the separable differential equations that we learned previously. We should talk about what first-order linear differential equations look like. They always look like this: dy dx plus some function of x times y to the first power. That's a terrible way to say it. Some function of x times y is equal to some other function of x. Dy dx plus some function of x times y is some other function of x. Vocabulary. It is first order because the derivative that's there is the first derivative. There is no second derivative in the differential equation. There is one derivative. It is the first derivative. Linear. It's linear because the power on y is 1. If the power on y is different than 1, then you don't have a linear differential equation. Okay, so these are the kinds of equations we would like to solve. And I think it's doable. I'd like to show you why the method we're going to study works. This is dy dx plus some function of x times y is some other function of x. So what I'd like to do is I'd like to multiply by some function v of x on both sides. I'd like to multiply by v of x. So I've got v of x times dy dx plus v of x, p of x, y is v of x, q of x. And you're thinking to yourself, what in the world is this? What in the world is this? Why would I multiply by something and make it look worse? And what is that thing anyway? Well, the insight that the mathematicians of the ages have had in this goes something like this. Take a look at the left-hand side. The left-hand side looks like it might be, this is trying to be, a product rule. It looks like this is first, this is derivative of second, and this is second, this is derivative of second, which means that if this is the derivative of the first, we win. If the derivative of the first is this, then this is a product rule problem. And so here's what we're going to say. We are going to say, here's the asterisk here, v of x is the function such that the product rule holds. And we will figure out what that function is soon. But suffice it to say, if this is the product rule, then the left-hand side is the derivative with respect to x of first times second. And the right-hand side is some function v times some other function q. So what does that mean? That means I can take an antiderivative here, antiderivative. And so when I want y by itself, I just divide by v. And I've got y all by itself. Now, here's the thing about that. You and I get to here and we say, wonderful, I know what y is. Y is 1 over v of x times the integral of v of x q of x dx. That's wonderful. I still don't know what v is. Well, let's figure that out, shall we? Remember what v of x was. V of x was the function such that the product rule holds. And for the product rule to hold, this has to be the derivative of that. The derivative of that has to be this thing. The derivative of v with respect to x has to be this, p times v. Wait a second. This is a separable differential equation. This is a separable differential equation. I can get all the v stuff to one side. I can bring the x up here, and I can take antiderivatives term by term. So the antiderivative here is the natural log of v. The antiderivative here is the integral of whatever p is. We don't know what that integral is, and it doesn't matter. But when I want v by itself, that's easy. V is e to the integral of whatever p is. And so in the following way, we can solve the first order linear differential equation, because whatever this is, once we know what p is in the context of the function, we can take its antiderivative, we can do e to the that, and that's our v, slam it, there, done. And you're going, you are going to have to show me something. And I intend to. Let's solve x times dy dx minus 3y is x squared with the y value when x equals 1 equal to 2. You can do this. So some questions to consider. Is it in standard form? And in standard form, we have dy dx, right? We have dy dx plus some function of x times y is equal to some other function of x. Is this in standard form? And the answer is no, because there's this x in front of the dy dx. So we're going to divide everybody through by x. Divide that through by x. Oh, mercy. I can just hit undo. Divide that through by x. Divide that through by x. Divide that through by x. Everybody gets divided by x. Once it is in standard form, p of x is whatever is multiplied by y, and q of x is whatever is hanging out here by itself like I was for so much of my childhood. Step 2, you're going to choose v of x. And remember that v of x is e to the antiderivative of p dx. Well, that's e to the integral of negative 3 over x dx. Well, what's the antiderivative of negative 3 over x? Well, that's negative 3 ln x. No constant necessary because it gets multiplied and divided through the problem, so you don't need that. A little bit of trickery with logs. This is the same as, right? 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 And we know that e to the natural log of whatever is whatever. So that helps us choose our v of x. Well, once we know what v of x is, this is easy because we just write down the general solution. And the general solution, you may remember, is that y is 1 over v of x times the integral of v of x, q of x, dx. Well, I know what 1 over v of x is. That's easy. Times the integral of v of x, q of x. Well, x to the negative third times x to the positive 1 is x to the negative 2. And the rest is super silly. The antiderivative here is negative x to the negative 1 plus a constant. And that's negative x squared plus c x cubed. So, step 4. After you have the general solution, solve the initial value problem. What did we know? We knew that when x was 1, y was 2. Well, that's easy. 1, 2 is my coordinate pair, so the y value is negative x squared plus some constant times 1 cubed. And that tells us that c is 3. And so the y is negative x squared plus c x cubed, and that solves the differential equation. Each time, 4 things to do. We're going to make sure that the differential equation is in standard form. We're going to choose our v by taking e to the antiderivative of p, no constant necessary. We're going to write down the general solution that we proved on the previous slide. And then we're going to use an initial condition if it is provided to us. Okay? Okay. I'm going to do one more. And then you're going to do one. And then we're going to be done. We're going to solve dy dx plus 1 minus 1 over x times y is x squared. And again, when x is 1, y is 2. So some things to consider. Is it in standard form? If it is, identify your v. Once you have that, you can write the general solution. So take a moment, identify whether this thing is in standard form, see if you can come up with a v. Is this in standard form? Yes. Dy dx plus some function times y is some other function. So p of x is 1 minus 1 over x, and q of x is the guy that's hanging out by himself over there. So what's v of x? V of x is e to the integral of p of x dx. So that's e to the integral of 1 minus 1 over x dx. So what's that? That's e to the x minus ln of x. Now, what does that mean? This minus sign means some things got divided. One of them is e to the x, the other is e to the ln of x. Sir, you said e to the ln x, but you wrote... Oh. So now what happens? The general solution is 1 over v of x times the integral of v of x q of x dx. 1 over v, well, that's just a reciprocal, times the integral of v of x q of x. That's x e to the x dx. How do you do that? This is integration by parts. And so I'm going to ask you to check me on this. That's x e to the x minus e to the x plus a constant. And you can certainly hit the pause button and work that through if you need to. That's integration by parts. You could do it tabular, you could do it not tabular, it doesn't really matter. It's integration by parts. So what is this? Well, if we distribute through there, we end up with x squared minus x plus some constant times x over e to the x. That is the general solution. Once we have the general solution, we can solve the initial value problem. And the initial value problem said that when x was 1, y is 2. So we sub in 2 for y and 1 for x. And we get that that constant c is 2e. So we get x squared minus x plus 2ex over e to the x. And we put a box around it. Okay, it's the same thing every time. So you may want to practice, and I would applaud you for doing so. Let's solve 3x dy dx minus y is 1 over x with y of 1 equal to 0. And that should give you a good idea of how this ends up working. If you're curious to check yourself, you should end up with something that looks like that. Boy, I hope that's what you end up with when this is all done. Okay, so you're well on your way. Thanks so much. See you soon.